Here we have a series of problems involving sectors. Let's look at the first question. We've got area of a sector is 24 centimeters squared and the angle contained in the sector is 60 degrees. Find the radius of the sector. So we know that 24 is equal to the angle over 360 times by pi r squared. So therefore if you rearrange that, this is just the same as 1 over 60, so therefore you end up, if you cancel that down, you get 1 over 60. So we can times her out by 60. So we get 24 times 60 equals pi r squared. Divide her out by pi and square root and we'll get what r is. 24 times 60 square rooted and divided by pi equals r. And that comes out as 6.7702 and so on. And to three significant figures at 6.77 centimeters. Let's look at the next question. A sector contains an angle of pi by 5 radians and the area of the sector is 30 centimeters squared. What is the radius of the circle? So we know that the area is equal to half r squared theta. So therefore 30 will equal a half r squared times pi by 5. Half times 1/5 is the same as 1/10. So if we times her out by 10, we'll get 300 equals r squared times pi. So therefore r must equal, divide by pi and square root, 300 over pi square rooted. And if we work that all out and do it to three significant figures, we get 9.77 centimeters. Sector has area of 12 centimeters squared and radius 4.2. So we know that the area equals a half r squared theta. So 12 equals a half times 4.2 squared times by theta. So therefore theta will equal, if you times by 2, so you get 12 times by 2, divide by 4.2 squared. So work that all out and theta comes out to be 1.3605 and so on. And to the nearest three significant figures, which is what we'll be doing so far in these questions, that's 1.36 radians. And we're going to work it out in degrees, so let's times that by 180 and divide by pi. And we get 77.922 and so on. So 77.9 degrees. Part D. The area of a sector is 45 and the radius equals 13.4. So the area equals a half r squared theta. So therefore 45 will equal a half times 13.4 times by squared times by theta. And therefore from that we can find out that theta equals 0.501 radians. You times by 2 and then divide by 13.4 squared. And from that we know that r theta, which is equal to the arc length. So what we're trying to do, we found the area. So we're given the area. We want to find the perimeter, and the perimeter is the radius plus the arc length. So the arc length, okay, is equal to r theta. And that comes out to be, r theta will equal 0.501 times by 13.4. So that will come out, that comes out 6.716. So the perimeter will equal two lots of radius are 2 times 13.4 plus 6.716, and we get the perimeter equal to 33.516, so on, which is 33.5 centimeters to 3SF. E, arc length 8.7 is equal to r theta, and we know the radius is equal to 9.2 theta. So radius is 9.2 times by theta. So theta will equal 8.7 over 9.2. Now the area equals a half r squared theta, so that will equal half times 9.2 squared times 8.7 over 9.2. I haven't bothered to work this out. You'll see why in a second. You'll see that we can cancel out one of the 9.2 squares. You've got 9.2 times 9.2, and you've got divide by 9.2, so you can cancel one of those out. So we're just left with a half times 9.2 times 8.7, and that comes out to be 40.2 to 3 SF. F. Now we've got this shape here, and we want to find this shaded area here. So the first thing we need to do is find the area of the triangle and the area of the sector. If you take the triangle away from the sector, you will be left with just the shaded area there. So let's do that. So the triangle, we know that the area of a triangle is equal to half AB sine theta, or sine C. There's A, there's B, and both of these are 5 centimeters each. So it's equal to a half times 25 times sine theta, which is 72. And that all comes out to give us 11.88 and so on. The sector, okay, is equal to theta over 360 times pi r squared, and that comes out to be 72 over 360 times pi times 25, and that equals 15.7, so on. So therefore the shaded area equals 15.7 minus 11.88, so on, and that comes out to be 3.81975, and to three significant figures that gives us 3.82 centimeters squared to 3SF. Part G, last question of this section on sectors. We've got the area of a segment, so we're given the segment in this case is equal to 20 centimeters squared, and the angle subtended by the chord, the chord forming the segment, so this chord gives us this angle, is 1.3 radians. What is the radius? We know that this area here, if we use what we did in the last question, was basically the area of the sector, which is a half r squared theta, minus a half r squared sine theta. Well, remember it's a half a. We use the formula half AB sine C. If you think of C as theta here, and A and B are both equal to the radius, then we see that it's a half r squared sine theta. In fact, we can take out a factor of half r squared. So there we know that A equals a half r squared, open brackets, theta minus sine theta. So times throughout by, we've got the area is 20, E equals a half, we don't know r, so r squared times theta 1.3 minus sine theta, sine of 1.3, and we Therefore times this by 2 to get 40, and divide by 1.3 minus sine of 1.3 to get r squared. That comes out to be 118.89 and so on. And if you square root both sides, you get 10.9 centimeters to 3SF.